welcome to another GCSE Physics revision video. This video is going to revise ideas about earthquakes, focusing on S and P waves. But to do that, we also need to revise some of the basics about the two types of wave as well. Sound waves and light waves are both examples where energy is being transferred by waves without transferring matter. Visible light is just one of the electromagnetic waves. Vibrations of electric and magnetic fields cause energy to be transferred at right angles to these vibrations. So light is a transverse wave. Another type of transverse wave can be seen on the surface of water. If you imagine a cork on the water, it would bob up and down as the wave passes. You can see this by watching the red dot. As it vibrates up and down, the wave is moving across the screen. The vibration is at right angles to the energy transfer. All of the electromagnetic waves are transverse waves. Sound is a different type of wave. It's a longitudinal wave. Particles vibrate to pass on the energy. The vibration is causing the energy to be passed on in a parallel direction to the vibration, moving away from the source. Watch the red line this time. It's vibrating back and forth as the wave moves across the screen. The vibration is parallel to the direction of energy transfer. The more densely packed the particles, the quicker they transfer the energy, which is why the speed of sound changes in different materials. For example, in air, it's only around 330 metres per second, but it's 1,400 metres per second in water and 5,790 metres per second in solid steel. So, transverse waves. The direction of the vibration is at right angles to the direction of the energy transfer. And you can see from the diagram here that I've labelled up for you some of the key parts we'd need to measure from that wave. The amplitude, the distance from the midpoint to the peak of the wave. Of course, that's the same as the midpoint to the trough of a wave. And also the wavelength, the length of one complete wave. That can be easily measured from peak to peak or trough to trough, as well as how I've labelled it here for you. And longitudinal waves, where the direction of vibration is parallel to the direction the energy is transferred in. These are the waves that have areas of compression where the particles are squashed close together, and areas where the particles are pulled apart as well. A wavelength can be measured from the centre of a compression to the centre of the next compression to show the length of one complete wave here. So how do earthquakes fit in? The Earth is not a solid ball. It's made up from layers. The inner core is very hot, very dense and solid iron. The outer core is also very hot and dense, but it's a liquid state, mostly iron. As we move out to the mantle, it's still hot, but less so, and less dense. Here it's a mixture of solid and molten rock, and it's in this layer that the convection currents occur. Finally, we reach the crust. This thin layer is made up of solid rocky tectonic plates. These tectonic plates are floating on the mantle, and they move very slowly because of those convection currents. There is a frictional force between the tectonic plates at the boundary. This stops them moving, but the convection currents are slowly providing a force to try and move them. Suddenly, the plates can slip. Friction has been overcome, and this sudden movement of the plates releases all that energy that's stored up in the compressed plates, releasing that energy as seismic waves. The place inside the Earth where the rock suddenly moves is called the focus of the earthquake, and the point on the surface of the Earth directly above the focus is called the epicenter. The tectonic plates have been mapped so we can predict where earthquakes are more likely to occur, but it cannot be predicted when they will happen. This is because we don't know exactly when the friction will be overcome. Scientists cannot measure the pressure between the tectonic plates, for example. Seismic waves are not only produced by earthquakes, explosions also produce the types of waves that we're going to need to study for our GCSE physics, those S and P waves. P waves, primary waves or compressional waves, are longitudinal. I remember these as push and pull waves. S waves, secondary waves or shear waves, are transverse. I remember those as shaking waves. When the tectonic plates slip and send out energy in all directions, the energy is transferred by both P and S waves. They are produced at the same time. But P waves travel faster than S waves. At a distance from the focus of the earthquake, both waves will transfer energy, but the P wave will arrive before the S wave. The further you are from the focus, the longer the gap in time between receiving each type of wave, which is called the SP time. Seismometers record the movement of the ground caused by seismic waves. A pen at the end of a heavy pendulum is placed above a drum which is rotating. This produces a trace called a seismograph, and that's produced on the paper as the ground vibrates. Modern seismometers use induced current to record the electrical signals from tremors. A magnet is suspended within a coil of copper wire. The shaking ground makes the coils move relative to the magnet, so a current is induced in the wire. The size of the current varies with the amount of movement and the speed of the movement. I digress. Let's get back to P and S waves. P waves are going to be demonstrated for us using this lovely slinky today with our normal volunteer helper. It's Tom.
How you doing?
But we also have someone to help us today to demonstrate our S waves, and that's George. Hi, George.
Hello.
George is here to help us too. So, with our slinky spring, Tom, can we please show everyone our P waves?
Okay.
P waves are longitudinal waves. They're the fastest of the seismic waves, travelling typically at about 10 kilometres per second. They can travel through solids and liquids. As the particles vibrate, they transfer energy in a parallel direction away from the focus. At a boundary between the different density layers of the Earth, they can be reflected and refracted. So it's over to George for our S waves. George is going to shake that slinky. So we've got our vibration up and down, and we've got the energy travelling away from the focus at right angles to the vibration. We've got a transverse wave. S waves are transverse waves. They travel slower than P waves, typically around 7 kilometres per second. They can travel through solids, but they can't travel through liquids. And then at a boundary between the crust and the mantle and the core, they are also reflected and refracted. Thank you, George. By tracing the paths of the S and P waves and their reflections and refractions, we get evidence for the theory of this layered structure of the Earth. Both P waves and S waves get faster as they move deeper into the denser layers of the Earth. This causes their refraction, and at boundaries between layers they're also reflected. Now only P waves reach the opposite side of the Earth, because S waves cannot get through the liquid core. This is because liquids don't have any shear strength, and the S wave is moving relatively slowly. So light, another transverse wave, can get through liquids, but that's because it's moving so fast. S waves cannot get through liquids. A network of seismometers around the world monitor seismic waves, and they can be used to pinpoint the epicenter of earthquakes. By measuring the time difference between the arrival of the P and S waves from the seismograph, the distance to the epicenter can be calculated. Don't worry, you haven't got to learn this formula, but what I'm showing you is if we know the speed of the P wave and we know the speed of the S wave, and we know the SP time, the time difference between when those two waves arrive at the point, that distance can be calculated. Using 3 such seismometer stations to calculate those distances, the exact location of the earthquake can be pinpointed. I hope this video helped you with your revision. If it did, thank Anna for requesting it, because Anna knows that
Regular review gets a better grade for you.
Don't forget to
Like,
so that I can keep making the videos.
comment,
Especially to request other revision topics,
subscribe.
so you can get notifications of when my next video gets uploaded.